Hello friends, in the last session on random access protocol, we have covered the details about max random access protocol like slotted ALOA and pure ALOA. In this session, we will cover other random access protocols like CSMA and CSMA CD in detail. In both the random access protocol, that is slotted ALOA and pure ALOA, which we have seen earlier, a node's decision to transmit is made independently and irrespective of the activity of other nodes attached to the broadcast channel. In particular, the node neither pays attention to whether another nodes happen to be transmitting when it begins to transmit, nor stops transmitting if another node begins to interfere with its transmission. In our social gathering analogy, Aloha protocols are quite like an ill-mannered person who continues to chat regardless of whether other persons are talking or not. As a human, we have human protocols that allows us not only to behave in a sophisticated civilized manner, but also to decrease the amount of time spent that is wasted in colliding with each other in conversation, and consequently to increase the amount of data we exchange in our conversation successfully. Specifically, there are two important rules for a polite human conversation. One is listen before speaking. If someone else is speaking, wait until they have finished. In the networking world, this is called as carrier sensing. That is, a node listen to a channel before transmitting. If a frame from another node is currently being transmitted into a channel, a node then waits until it detects no transmission for a short amount of time and then begins transmission. The other rule could be if someone else begins talking at the same time, stop talking. In the networking world, this is called as a collision detection. That is, a transmitting node listen to a channel while it is transmitting. And if it detects that another node is transmitting an interfering frame, it stops transmitting and wait a random amount of time before repeating the sense and transmit when idle cycle. These two rules specifically listen before speaking, and if someone else begins talking at the same time, stop talking. These two rules are embodied in the family of carrier sense multiple access CSMA and carrier sense multiple access with collision detection, that is CSMA CD protocols. Many variations on CSMA and CSMA CD have been proposed. Here we will consider few of the most important and fundamental one, that is CSMA and CSMA CD. The first question that might be crop up in our mind, that is why, if all nodes perform carrier sensing, do collision occur in the first place? As in case of CSMA, when all the nodes which were involved in the transmission were sensing the communication channel before beginning the transmission, then why there is a collision? After all, a node will refrain from transmitting whenever it senses that another node is transmitting. Answer to the question can be best illustrated by using this particular space-time diagram. A space-time diagram having four nodes A, B, C and D. attached to an linear broadcast bus, common bus. The horizontal axis shows the position of each node in a space, and the vertical axis represents the time. At the time t0, node B says the channel is idle. The node B says that channel is idle, and no other nodes are currently transmitting. At this point time t0, this particular node B has says that the channel is idle and no other node is using the channel. Node B thus began transmitting the data. Its bit propagating in both directions, forward as well as backward, along the broadcast media. The downward propagation of B's bits with increasing time indicates that non-zero amount of time is needed for B's bits actually to propagate along the broadcast media. The bits transmitted by B are propagating in both directions, in forward, downward direction as well as in forward direction. At time t1, where t1 is greater than t0, as it was shown in the time axis, node D has a frame to say. Although node B is currently transmitting at time t1, the bits being transmitted by node B have yet to reach to D. Here, this particular line indicates that the bits inserted by node B in the channels are propagating, and it takes some time to get propagated, and which may be sensed by the node D. But in between, suppose at time t1, which is greater than time t0, at any time t1 which is greater than t0, node D has data to send. As these bits are yet to reach to the node D, node D assumes that the channel is idle. But node B has already started its transmission at time t0, which results in both the node B and node D are transmitting the data simultaneously. In accordance with the CSMA protocol, D has begun transmitting its frame because it fails to sense the availability of another node in the channel. As bits belongs to node B takes some time, that is propagating time, to get sensed by node D. A short time later, B's transmission began to interfere with D's transmission. At certain time, specifically here, node as again that node B data is start transmitting propagating in both direction. At this particular time juncture, node D starts to recognize that there is an interference. From this figure, it is evident that end-to-end channel propagation delay of a broadcast channel, that is the time it takes for a signal to propagate from one node to another, will play a crucial role in determining its performance. Because of the property of the media which is used for transmission channel, bits or data takes certain time, that is called as propagation time, to be get sensed by other node, and that will play the vital role in determining the performance. The longer this duration time, the larger the chance that carrier sense node is not able to sense the transmission. that has already begun at by another node in the network. In carrier sense, multiple access, that is CSMA as discussed, node do not perform collision detection. Both node B and node D continue to transmit their frames in their entirety even though collision has occurred, which we had seen earlier. Whereas in case of CSMA-CD, that is carrier sense multiple access with collision detection, when node performs collision detection, it ceases transmission as soon as it detects a collision. As shown in this space diagram, this is a typical time wherein the node B and node D are in position to detect the collision. Two nodes each abort their transmission short after detecting a collision. At this instance of time, when node B and node D detects the collision, in very short duration of time after this duration, both node or the node involved in the collision may cease the transmission. Clearly, adding collision detection to a multiple access protocol will help protocol to enhance the performance by not allowing transmission of useless damaged frame in its entirety. That is, instantaneously after detection of the collision, instead of allowing that collided or corrupted frame to transmit, both the nodes which were involved in collision will cease the transmission instantaneously. Thus, it results in enhancement in performance as compared to pure CSMA. Before analyzing the CSMA CD protocol, let us now summarize its operation from the perspective of an adapter in a node attached to a broadcast channel. The adapter, that is NIC, obtains a datagram from the network layer, prepares a link layer frame, and puts the frame adapter buffer. If the adapter senses that the channel is idle, that is, there is no signal energy entering the adapter from the channel, it starts to transmit the frame. If on the other hand, adapter senses that the channel is busy, it waits until it senses no signal energy and thus then start to transmit the frame. While transmitting, the adapter monitors for the presence of signal energy coming from other adapter using the same broadcast channel. If the adapter transmits the entire frame without detecting signal energy from other adapter, the adapter is finished with the frame. If on the other hand, adapter detects signal energy from other adapter while transmitting, it aborts the transmission. That is, it stops transmitting its frame. After aborting, the adapter waits a random amount of time and then return to step 2 again. This will continue. The needs to wait random rather than a fixed amount of time is hopefully clear. That is, if two nodes transmitted frame at the same time and then both waited for the same fixed amount of time, they would again continue to collide forever. But what is a good interval of time from which to choose the random backup time? If the interval is large and the number of colliding nodes is small, nodes are likely to wait large amount of time. That is, channel remains idle before repeating the sense and transmit when idle steps. On the other hand, if the interval is small and the number of colliding frames is large, it is likely that the chosen random value will be nearly same and the transmitting nodes will again result in collision. The best solution is the binary exponential backup algorithm, which is used in Ethernet, elegantly solve this problem. Specifically, when transmitting a frame that has already experienced an collision, node chooses the value k at random from the set 0, 1, 2 up to 2 raised to m minus 1. That is, when transmitting a frame that has already experienced an m collisions, node chooses the value k in such a fashion that the value belongs to 0, 1, 2 up to 2 raised to m minus 1. Thus, more collisions experienced by a frame, larger the interval from which k is chosen. Size of sets from which k chosen grow exponentially with the number of collisions. For this reason, this algorithm is referred as binary exponential backoff. For example, after a second collision, k is chosen with an equal probability from the set 0, 1, 2, 3. That is 2 raised to 2, second collision. After 3 collision, the k is chosen from the equal with an equal probability from the set 0, 1, 2, 3, 4 up to 7. That is 2 raised to 3, being a third collision. Likewise, number of elements in the set goes on increasing with the number of collisions. Thus, more the collision experienced by the frame, the larger the interval from which key is chosen. For Ethernet, the actual amount of time the node waits is given by k into 512 bits time, where 512 bits time is equal to 0.01 microsecond for an 100 Mbps Ethernet. The maximum value that n can take is capped at 10. For example, suppose that node attempts to transmit a frame for the first time, and while transmitting it detects a collision. Then node waits, node chooses k, that is 0, where k belong maybe from 0 and 1 being a first collision, that is 2 raised to 1, two values 0 and 1 with a probability of 0.5, and k chooses as 1 with a probability of again 0.5. If the node chooses 0, then it immediately begins sensing the channel. And if the node chooses 1, it waits 512 bits time, that is 0.01 microsecond. Thus, the size of set from which the value of k is chosen grows exponentially with the number of collisions. For this reason, this algorithm is referred to as binary exponential backup algorithm. When only one node has a frame to send, node can transmit at the full channel rate. For example, for Ethernet, typically rates may be 10 Mbps or 100 Mbps or 1 Gbps. However, if many nodes have a frame to transmit, the effective transmission rate of the channel can be much less. We define the efficiency of CSMS with CD to be the long run fraction of time during which frames are being transmitted on the channel without any collision. When there is a large number of active nodes, each node having a large amount of data to send. In order to present a closed form approximation of the efficiency of Ethernet in case of CSMA with CD, let us assume that D prop is the maximum time it takes signal energy to propagate between any two nodes, any two adapter, and D trans the time to transmit maximum size frame, that is approximately 1.2 millisecond for 10 Mbps Ethernet line. Derivation of efficiency of CSMA with CD is thus given by efficiency equals to 1 upon 1 plus 5 into D prop divided by D trans. And it is apparent from this formula that the value of D prop, as the value of D prop approaches 0, the efficiency approaches to 1. This matches our intuition that if the propagation delay is 0, colliding nodes will abort immediately without wasting the channel. Also, as D trans becomes very large, efficiency approaches 1. This is also intuitive because when a frame grabs the channel, it holds on the channel for a very long time. Thus, the channel will be doing productive work most of the time. Here in this session, we have covered the details about max random access protocol like CSMA and CSMA CD. In the next session, we will discuss about yet another type of multiple access protocol, that is talking tom. Stay tuned. Thank you.